Hello everyone, welcome to my YouTube channel. In this video, I am going to show you one of my project for animal rescue location optimization that we can do using Solver. So let me show you the problem statement. It says that in Marion County, we have 4 different towns, town 1, town 2, town 3 and town 4. And they provided the X and Y coordinate for those 4 different locations. And they also provided that for each of those towns, how many rescue they have done per year. Okay, average rescue. So you can see town 1, the average rescue is 200. For town 2, that's 300. For town 3, that's 400. And town 4 is 250. Now, what we need to do, we need to find a shelter location. That means X and Y coordinate for that particular shelter, for which we will get the minimum travel distance. But the travel distance is not calculated based on the Euclidean distance formula. They calculated that like you need to go in the X direction and then go up or down. Okay, so it's like subtract the X coordinate between 2 points and then get the absolute value of that, plus Y coordinate subtraction and get the absolute value for that one, and then sum it up, and that will give you the travel distance. So we can extract the basic information from this section and then we can set up our solver model. Okay, so you can see that I have 4 different towns, I have 4 different X coordinate and Y coordinate, and this is the average rescue per year. Now let's consider that this is my variable, right? I need to find the X and Y coordinate, right? So I can just provide any number, 200, let's say 300 or so on, right? So this is my shelter X coordinate and Y coordinate. Now I have some constraint that, okay, I have provided that this is the X coordinate, so I can find the feasible X coordinate minimum out of this, and maximum is going to be the max of this coordinate. So what I want to do, I want to place the shelter location in between these 4 towns so that it can be like, in the center position, so that we can have minimum travel distance. So I get the minimum and maximum using min function and max function for X and Y coordinate. That's the same thing. And this is my decision variable, so I just provided that, okay, this is 200, 300. You can provide any number you want, right? Now you can see the town distance. The calculation method is that you need to subtract the X and Y coordinate and then sum it up based on the absolute value, right? So that's why H4, so that is this H4, and then minus T4, that is basically for town 1, and I4, that is basically Y coordinate, and then E4, that is basically town 1 Y coordinate. And then we subtract that and then get the absolute value, and we can just sum these 2 up. That will give you the town distance, right, from the shelter location to the particular town. Now you can just drag the formula and this will give you all 4 town distance. Now for each year we have 200 rescue per year for town 1, so we can calculate the total distance throughout the year for that particular town. So that's just multiplication, right? 150 multiply by 200 and multiply by 2, because you need to go to that particular town and then come back, right? So the distance is twice, that's why just multiply by 2. So that is the total distance per year for each of this town. Now if I want to get that average distance per rescue, right? So we have total rescue for all of those 4 towns is around 1150, and we get total distance for each year by summing it up, and that is this number, right? So we can just divide it by this total number of rescue, and that will give you the average distance per rescue. So what's our objective? What's the objective function? The objective function is that you need to minimize this average distance per rescue, right? So minimize this one. What's the constraint? The constraint is that normally, as you can see, all of these town X and Y coordinate are integer. So I'm going to consider that our expected output, so that is shelter X coordinate and Y coordinate, should be an integer. Okay, so that's one constraint. The next constraint is that this shelter X coordinate should be greater than or equals to minimum X coordinate and less than or equals to maximum X coordinate. So it resides in between these 4 terms, right? So that's 4 constraint. Okay, one is for X minimum coordinate, one is for maximum coordinate. So in the same way, Y coordinate constraint, and that's it. Then you can just set it up and then it will solve that particular model. And you can see we have set objective, so that objective is M4. So basically that is this one, average distance per rescue. And you can see by changing variable cell, so variable cell is basically this H and I. That's my variable cell that I want to change, and I want to get the information for that one. And these are my coordinate that it's need to be, you can see H4, so that is X coordinate, right? H4 it's need to be less than or equals to d13, that is this max coordinate, and it's need to be greater than or equals to d12, that's the minimum coordinate. Now you can just click on this solve, and then it will solve that, and then it will show you that okay, this is my answer, 619270. okay, and I'm using this GRG nonlinear module, and that is because that I have absolute function. Okay, as you can see, the distance calculation in this section is like absolute h4 minus t4, absolute i4 minus e4. So whenever you have a decision variable and you need to calculate the absolute value for that one, then it's become non-linear model, it's not linear anymore. Okay, that's why we are using GRG non-linear. Now we have a way to convert that non-linear model to a linear model, and that will be my second video on this particular topic. And you can see I have another sheet for this linearity. That's it for this video. If you understood this video, please consider subscribing. Have a good day.